Cellular senescence is biology's version of hitting the brakes hard. When a cell becomes damaged, stressed, or reaches the end of its replication limit, it enters a state where it can no longer divide. It's not dead, but it's not pulling its weight either. These senescent cells hang around like cranky neighbors. They secrete inflammatory molecules, disrupt tissue structure, and send bad vibes to nearby healthy cells. Over time, the accumulation of these cells contributes to aging in the skin, immune system, blood vessels, and even the brain. But what if your morning coffee could gently push back against that tide? It turns out caffeine might be doing more than perking you up. It could be slowing down the biological clock at the level of your cells. In lab experiments, particularly those using human fibroblasts, the skin cells responsible for collagen production and repair, caffeine has been shown to reduce markers of cellular senescence. For example, in cultures where cells are pushed toward premature aging, either through oxidative stress, UV damage, or repeated divisions, caffeine appears to lower the expression of P16-INK4A and P21, two classic senescence-associated genes. It also reduces the activity of senescence-associated SS-galactosidase, a blue-staining enzyme that basically screams, "This cell is done." Cells exposed to caffeine tend to divide a few more times, produce less inflammatory gunk, and maintain more youthful morphology, less flattened, less frayed, and more functionally sharp. The mechanisms behind this anti-senescent effect seem to involve several cellular defense pathways. Caffeine mildly inhibits ATM/ATR kinase activity, which is part of the DNA damage response system. By modulating this pathway, caffeine may reduce unnecessary or excessive activation of senescence in mildly stressed cells, especially when damage is reparable. It also appears to enhance DNA repair enzymes, possibly helping cells clean up damage before they decide to give up entirely. And through YMPK activation, caffeine promotes autophagy and mitochondrial maintenance, two processes that keep cells energetically fit and less prone to collapse under stress. In immune cells, particularly T cells and monocytes, some lab studies have shown that caffeine may help preserve function and reduce senescence-related markers as well. Senescent immune cells are notoriously pro-inflammatory and contribute to what scientists call inflammaging, a chronic low-grade inflammation that underlies many age-related diseases. By dialing down this inflammatory output and supporting better mitochondrial function, caffeine could help maintain a more youthful immune profile, at least in vitro. Now, these are mostly cell culture studies, carefully controlled petri dish environments where caffeine can be precisely dosed and effects measured over a short period. It's not the same as drinking a cappuccino and watching your wrinkles vanish. But they do provide plausible biological mechanisms that support what epidemiological studies have been telling us. People who drink moderate coffee have lower rates of age-related diseases, better skin elasticity, and stronger immune responses in old age. There's also emerging interest in topical caffeine formulations, especially for skin aging. Applied directly to the skin, caffeine has been shown to reduce oxidative stress, increase microcirculation, and improve the appearance of photo-age skin. While these aren't strictly senescent studies, they suggest caffeine has local, skin-relevant bioactivity that could interact with fibroblast health and turnover. Could caffeine delay cellular senescence in humans in a meaningful way?
Possibly.
It's not a senolytic drug. It doesn't kill off old cells, but it might act as a senomorphic, changing how these cells behave or preventing some cells from entering senescence too early. It won't freeze aging, but it may slow the speed at which your cells surrender to it. So the next time you sip your coffee, consider this. While it's fueling your brain, it might also be coaxing your skin cells to hang in there a little longer, patch up their DNA, clean out their trash, and put off retirement. Not a bad job for a molecule most of us meet before 9 a.m.